This is just an informal overview of a typical path for creating drawings to be used in 3D printing. A lot of drawings start as two-dimensional, and Autodesk or AutoCAD is one of the main utilities to do that. One of the advantages is that you can create very precise line drawings. The export for that would be either DWG or DXF. It would be actually a saved as, and that would be taken to a 3D package that would allow you to do your modeling. Now, AutoCAD can also be used for 3D modeling, but some people find it more expedient to use a different 3D modeling package to uh, drag and drop templated shapes and to work more efficiently. My 3D package of choice is 3D Studios Max. And with that, I would import the DWG or the DXF file. I can also import from other sort resources three-dimensional files to be used, say for a threaded screw or something like that. But as a 2D shape in 3D Studios, I can use various tools to extrude it, to use Boolean cutouts, and various manipulations of the primitive geometries and some of the more complex geometries to create my object. From there, I would export it as an STL file. Now, 3D modeling packages, depending on that specific package, have a level of reliability in terms of missing objects, the joining planes, things like this. And so a lot of times they have to be mended. And there is several mending utilities, but the one that is most dependable is a utility from Microsoft that is cloud-based. The problem with this one is it works very, very well. They decided to make it proprietary, and it generates a 3MF file, which is very difficult to find a utility that reliably converts it back to the STL file that the 3D modeling packages want. Meshmaker is one of those utilities that reliably converts the 3MF file to an STL file. Once we have a mended STL file that has a reliable geometry, then we can import it into a slicing or G-code utility, machine code utility like Cura. Cura is very good and uses many templates for various printing machines. It also allows you to evaluate the slices for the integrity of those slices, and you can actually identify if there's still mistakes in the model by being able to look at it layer by layer and make sure that everything joins up. In terms of the controls, it also controls the heat of the head and the table of the machine, the millimeters of thicknesses for various elevation and wall thicknesses, also the speed of the printer. There's also a term called retraction, which when your printer head has to skip from one place to another, the head actually draws the filament back up for a microsecond and then puts it down again. So there's lots of variables that you can set with the Cura program, as well as evaluating the integrity of the slices. So from there, you can either export it as a G-code format and load it onto an SD chip and put the SD chip in your machine, or like many do, you can connect directly to your printer with a USB and be able to just send the G-code directly to the execution of the file and the creation of the 3D model. So that's pretty much it. I hope it's helpful, and there you go.